In 1977, a rare alignment of the outer planets occurred, something that only happens once every 176 years. Don't worry, this isn't an astrology video. This is about the Voyager probes. NASA took advantage of this alignment to launch two probes that would forever revolutionize our understanding of the solar system. Voyager 1 and 2 sped off to explore Jupiter, Saturn, Uranus, and Neptune. Thanks to clever gravity assists, which catapulted them from planet to planet like billiard balls. During a gravity assist, a spacecraft flies past a celestial body and increases its own speed. By doing so, it steals a tiny bit of energy from the assisting body. They definitely wanted to take advantage of this extremely rare alignment. That's why there was enormous time pressure, because without this perfect alignment, the mission would have become impossible. More fuel, longer flights, a more complex mission architecture, and therefore higher costs. Instead, it became one of the most efficient journeys of all time. The twin pair has been traveling for 48 years and is still helping us today to unravel the mysteries of our solar system. Buckle up, because this will be a turbulent journey through technological innovation, visions, mysterious discoveries, unexpected obstacles, and much more. I'm Serwan, and this is Mars Chronicles. Let's go! Let's start with the why. This planetary alignment made it possible to cover maximum distances with minimal effort. Funnily enough, Voyager 2 was launched first and only then Voyager 1. Voyager 2 launched on the 20th August 1977 and used Jupiter's gravity to gain speed and swing by Saturn, then to Uranus and on to Neptune. Voyager 1 launched about 2 weeks later on the 5th September, following focused on Jupiter and Saturn, but then turned off into interstellar space. In other words, it left the plane of our solar system. Each gravity assist saved tons of fuel. Physically speaking, they used the kinetic energy of the planets to boost their own speed without burning a single extra drop. Imagine you're swinging around a corner on a rope. That's exactly how it works, only with billions of kilometers and gravitational fields. Without this precise timing, the mission would have been delayed by decades. And who knows if the budget would have held up. Speaking of the budget, the entire Voyager program cost around $865 million at launch, which, adjusted for inflation to today, October 2025, is about $4.2 billion. The program still costs NASA about $5 million per year to maintain contact. Sounds like a lot. Compared to modern projects like the James Webb Space Telescope, which has consumed over $10 billion, or the Space Launch System program with its billions per launch, that was a bargain. For two probes that deliver data for decades, that's a return on investment you can be proud of. Less than the daily interest on the US national debt, as some sources mock. And that includes launch operations and the iconic golden records. Today, such a mission would be much more expensive. But thanks to efficiency, we have converted over 11,000 work years into knowledge so far. The launches themselves were on Titan III, i.e. Centaur rockets, mighty beasts with a payload capacity of over 15 tons to low Earth orbit, or 3.7 tons to Mars. The Titan IIIE, a derivative of the Titan family that originated from intercontinental ballistic missiles, or ICBM, combined solid rocket boosters with a high-energy Centaur upper stage that use cryogenic fuels like liquid hydrogen and oxygen. Each launch cost around $72 million in 1970s prices. Adjusted for inflation, that's nearly $400 million US. Martin Marietta, a subsidiary of General Dynamics, which is now part of Lockheed, achieved the goals that were set. I explained why rocket launches were so incredibly expensive in my video last Sunday.
Link them below. Develop why rocket launches.
But at least the rockets were reliable. 7 launches between 1974 and 1977, including the Voyager's 5% crosswise rudder magic. On board each probe was an arsenal of technologies that were revolutionary for the 70s. 10 scientific instruments, including cameras for high-resolution images, magnetometers to measure magnetic fields, plasma sensors for charged particles, ultraviolet spectrometers, and detectors for cosmic radiation. All powered by 3 radioisotope thermoelectric generators. Using plutonium, they convert heat into electricity. Initially 470 watts, today only about 250. The computers had 69 kilobytes of memory, less than a modern emoji, but robust enough for decades. And yes, there were obstacles. Voyager 1 had a computer glitch in 2023, sending only binary garbage for months caused by a faulty chip. Engineers fixed it with a software patch from 24 billion kilometers away. Voyager 2 lost its plasma sensor in 2024 to save power. And recently, on both, the low-energy charged particle detector and other instruments were deactivated. The charged particle will keep running until the end of 2025. Then it will be turned off. Failures like nozzle problems were fixed with backups. And with a diameter of 3.7 meters, they transmit with only 23 watts. Weaker than a light bulb, but focused enough for the deep space network. Their paths? Both probes have left our solar system and are now in interstellar space. Voyager 1 is now 25.2 billion kilometers from Earth, or 168 astronomical units. Even light takes 22.5 hours to cover this distance. An astronomical unit is the distance from the Sun to the Earth. Voyager 2 is 20.8 billion kilometers away, or 139 astronomical units. Voyager 1 left our solar system in 2012 and Voyager 2 in 2018. There, the solar wind keeps decreasing. We've now learned a lot about these impressive Voyager probes, but also technical details and the challenges they have overcome. But let's finally get to what really makes them immortal. They're groundbreaking discoveries that have forever changed our understanding of the solar system. Where do I even begin? Let's start with Jupiter, where Voyager 1 was the first to detect lightning in the dense atmosphere of the gas giant. That was the very first time we observed thunderstorms outside of Earth. A hint at how dynamic and stormy these worlds can be. Even more exciting were the volcanoes on Jupiter's moon Io. The probe discovered active eruptions that hurl sulfur and gases into space, proving that there is geological activity on other moons. No one had thought this was possible before. In addition, there were thin, previously unknown and small particles, as well as 3 new moons, including Phoebe, which showed us how diverse the Jovian system really is. These images and data were real bangers and kept astronomers busy for years. By the way, if you want to get news like this and other updates from space exploration directly in your inbox, sign up now for the Mars Chronicle newsletter for free at Mars Chronicle Space. The link is below in the description. Next up, Saturn. Here, Voyager 1 discovered complex structures in the famous rings. For the first time, we could see how the rings are crossed by thousands of small waves shaped by the gravitational forces of the moons. A breathtaking pattern of ice and rock that looks like a cosmic work of art. The probe also revealed the thick, nitrogen-rich atmosphere of Titan, which is so hazy that it looks like a mini-Earth with methane lakes and rain. And that immediately sparked dreams of potential organics or even life. And not to forget, 5 new moons were discovered, making the Saturn system even more mysterious. These observations helped us understand how rings form and survive, and they continue to inspire missions like Cassini to this day. So go ahead and click the link below. Voyager 2 took over the baton for the outer planets. And at Uranus, it encountered a real mystery. 10 new moons, including Park and Miranda, with their rugged surfaces and a magnetic field that's completely tilted. Unlike most planets, it lies almost on its side, which suggests an ancient collision. That completely turned our models of planetary magnetic fields upside down and showed how unique each ice giant can be. Things got really stormy at Neptune. The probe observed a wild atmosphere with the fastest winds in the solar system, up to 2,000 kilometers per hour, and dark spots like the Great Dark Spot, which acts like a giant hurricane. On Neptune's moon Triton, it discovered geysers that spit out nitrogen, a sign of cryovolcanic activity in the cold depths of space. That was a complete surprise and taught us that even the most distant worlds can be alive. And then in interstellar space, where the probes have been traveling since 2012 and 2018 respectively. Here they provide data on cosmic radiation that reveals to us what the edge of the heliosphere, this protective bubble around our solar system, is really like. Instead of the strong magnetic fields predicted by the models, they unexpectedly found weak fields and a higher density of galactic rays, which means that the transition into real outer space is more gradual than we thought. These measurements help us to better understand cosmic radiation. It poses a threat to astronauts on long journeys, and they are a window into the vastness beyond our system. It's fascinating how these old probes are still telling us new stories decades after their launch. The golden records on board the Voyagers are a true masterpiece of humanity. Two 12-inch discs with a copper core, coated with pure gold, meant to serve as a message to the universe. Each contains 115 carefully selected images, ranging from breathtaking Earth landscapes and diverse people and cultures to mathematical formulas and scientific diagrams, all meant to represent our knowledge and our world. In addition, there are natural sounds like the crashing of waves, the howling of the wind, birdsong, and the deep calls of whales, capturing the diversity of life on our planet. A total of 90 minutes of music fills the records, with classics like works by Bach and Beethoven, the rocking Johnny B. Good by Chuck Berry, and traditional pieces from cultures around the globe. From Peruvian flutes to Indian raga vocals. There are also greetings in 55 languages. Wishing everyone peace and happiness. Kokwai huma tsuk kokwai adanesh lushulmu. Including ancient ones like Akkadian and more widespread languages like Arabic, Mandarin, and English to show the range of our communication. There are also more detailed benevolent messages on it. But right at the beginning, there are two skippable ads. But all jokes aside, the whole thing is complemented by a silicon carbide needle for playback and detailed instructions on how to use the record, including symbols for speed and stereo. Additionally, each probe carries a plaque with schematic drawings of Earth, the solar system, and the positions of pulsars as cosmic coordinates to mark our origin. Basically, it's a perfect time capsule intended for curious aliens. They might find it someday, or for ourselves in a distant future in case we ever come by again. Personally, I think that's one of the most beautiful things humanity has ever done. We reached out our hand without knowing if it would ever reach anyone. I've linked the entire contents of the record below, but what are actually the last messages we received from the probes? As of October 2025, both Voyager probes are still sending valuable data back to Earth. Voyager 1 recently reported on the intensity of cosmic radiation, giving us insights into the radiation environment beyond our solar system. Meanwhile, Voyager 2 is transmitting data on plasma waves. These help to better understand the dynamics of the interstellar medium. However, the available power is steadily decreasing in about 4 watts less per year as the radioisotope thermoelectric generators are gradually weakening. Communication could last into the late 2020s, maybe even until 2030, as long as the generators provide over 200 watts. But a looming 26% budget cut to the Voyager project could end the mission earlier, as recent reports suggest.
And what happens after that?
The probes will continue traveling forever. Voyager 1 at 61,500 kilometers per hour toward the constellation Ophiuchus, and Voyager 2 at 55,000 kilometers per hour toward Pegasus. In about 40,000 years, Voyager 1 will pass by the next star, Gliese 445, at a distance of 1.7 light years. And altogether, they will travel for billions of years as silent ambassadors of humanity, which may one day be discovered by other civilizations. Voyager has shown us how far we can go with greatness and skill instead of just pure budget. The challenges from failures to power management make it exciting. And those discoveries still inspire us. Soon communication will end, but its legacy is infinite. If you enjoyed this journey with the Voyager probes, subscribe to Mars Chronicles and give it a thumbs up. Big thanks to all channel members and Patreon supporters. If you also want early access to our videos, you can find all the information about it below in the video description. I'm Serwin, and this was Mars Chronicles. Thanks for listening. Per aspera ad astra.